What is up, folks? This is Cargo here. We are doing some things today, and those things are mainly that I need to show you guys how we're going to implement scheduling processes on this operating system. So, so yeah, that's pretty much all that's up. Great start to a Friday, you know. Friday morning, you just sit down and code. I don't know how true that actually is. I don't know if I'm like saying that with like tears going down my face or like. Anyways, let's just get something set up real quick. Cool. Okay. And one more. Here it is. Perfect. All right. So, as I was saying, oh, that should not be there. This should not be here. Oh no. I'm just accidentally pressing a lot of tabs that I don't intend to press. Okay. So, here is our code. Let me know if it is like too small, but I think it should be okay. But okay, essentially, so what we've implemented so far is so without going too much into details and stuff like that, I'm gonna close some of this like less important stuff, so that it doesn't look like there's just a shit ton of files open. Yeah, we can close all these too. Honestly, the only one we really need is proc.c. Okay, so before, so if I come down here, so we have a scheduler function, and this scheduler basically, as the name suggests, it schedules processes to run on the CPU or the multiple CPUs, potentially multiple cores, if you will. And so the way it determines that is it has to have some sort of scheduling policy. So what existed before is, let me uncomment this real quick. So what existed before is basically it would go through our table of processes. So we have a table of 64 processes, and it would go through the whole thing, and it would check every single process to see if it was runnable. And if it was runnable, then it would run it. And so what this is called is round robin. Well, not necessarily, but what makes it round robin is the other kind of half of this here, where essentially, so here in our trap handler, we basically have a timer that goes off every, let's say like, okay, I guess it doesn't tell me. Let's say like every like 100 milliseconds or something, the trap timer goes off here for the scheduler. So what we can do then is basically we can say, okay, like if the process hasn't finished running in 100 milliseconds, then we're gonna say, okay, your turn's over, let's go to the next process. And so that's what this yield function is. So that's all we're doing here. So if process 1 doesn't finish in 100 milliseconds, we go to the next process. And so that's how this works, right? So we switch into that the process using this switch function right here, and then once it gives up control back to us, whether it finishes or whether the timer kind of says, okay, your time's up, the control will come back to this function, and then we'll switch back to the kernel, let's switch KVM, and then we'll go to the next iteration of the for loop, right? So if we ended on process 3, right, we run process 3, and then we come back, and then on the next iteration, we're going to look at process 4 in the table. That's essentially what's going on. And so then we'll check, oh, is process 4 runnable? If it isn't, then like, you know, keep going, check process 5. But if it is runnable, like let's schedule it, let's run it for, you know, however long. Again, whether it finishes or whether it takes the full 100 milliseconds and doesn't finish. And then, yeah, the cycle will just continue until we get to process 63. Our process table is 64 entries wide. So once we pass process 63, we're going to exit the for loop because of our condition here. It'll stop after that. And then this is all new code here that I've written, but essentially we'll exit out of this for loop and then we'll loop right back to the beginning of the for loop again because of this outer for loop. The scheduler will just keep running basically for eternity, which is kind of funny. But yeah, that is pretty much all there is to it. I know it says that there's 232 changes to files over here. I assure you that is not correct. Oh, you know what? In fact, I think that is because of this folder specifically. So if I don't need this folder. I can just delete that. 14. That is much more like a good number, a good representation of how many folders I've, or how many files I've modified or created. I guess it also added my settings. I don't know why. Oh well. So yeah. So essentially, what's going wrong right now is so we can uncomment or we can comment this back out, and so I have to add Fifo scheduling, which is first in first out scheduling. Differs from round robin in the sense that once like a process has come up and it has been scheduled, like it should be allowed to continue running until it's like totally done, or if it like voluntarily gives up control. And once that happens, then you can schedule the next process that came in the order in which they like came into the CPU. So how I was doing that right now, and there are going to be some problems. There are going to be some problems with the way that I put this together. It does not work. I can tell you that right now. Is I was trying to essentially go through the whole process table and find the oh, excuse me. I was trying to find the best process to run. And I was like, I don't know. I wasn't using an actual Fifo Q. I was trying to schedule based off of the PID, which is just not correct, as I found out, because what can happen. So the PID is assigned sequentially. This is a process ID. So it's assigned sequentially, and so although like you would think like, oh, when you create a process and assign it a PID, then like that should be the order that it came in, right? But what can actually happen though is that what if we run a Fifo process for a while and then it decides to go to sleep or something like that. It like gives up control, right? Then like when that process becomes runnable again, like it would not be at the front of the Fifo queue anymore. Despite having the earliest PID, it wouldn't be at the front because it kind of relinquished, it gave up its position when it decided to not be runnable anymore. So we need to implement an actual like linked list or something like that in order to deal with that. So we could probably just get some quick source code or something like that from the interwebs. I don't really have too much intention of actually writing out a full linked list kind of thing there. But yeah, okay. So first thing that I want to do is essentially let's go into let's go here, right? So this is where we're yielding. So technically we don't want to yield in the case that that there isn't a better process to run, or in the case that we're running a Fifo process, like the Fifo wouldn't yield on a timer. But we're going to use this yield. We're going to use this yield function anyways, just so that we can like go back into the scheduler and make sure that the process we're running is still the best process to run. So yeah, so we'll yield, right? And the yield will take us into here, our scheduler. I got another sneeze coming, I think. No, we're good. Okay. But so yeah, so we're gonna come in here and essentially. So first of all, I want to hold on. This music is a little bit too loud. I don't even know if that. I don't even know if I reduced the volume. Oh well. But yeah, essentially, what we want to do here is, first of all, we want to split kind of our logic into, oh, are we dealing with a FIFO process? Like, are we going to be scheduling the FIFO process, or are we going to be scheduling a round robin process? And the way we can make that decision, so according to the spec that we're working with here, FIFO policy processes always run before round robin policy processes. So that's the spec we're working with. That's kind of how we're gonna work here. So what we'll do in our scheduler, immediately after we acquire the p table log, and I'm actually just gonna just comment all of this out. This code will stay the same. This is the code that we actually use to like schedule the process, so that's not gonna change. But how we determine like what the best process is will change. So we'll keep an eye out for that. But yeah, so okay. So we have our old method. We have our I'm gonna call this the old new method. And then we're gonna have our new method now. And maybe the new method will work this time. So we're going to I'll actually do this like a bullet point list. So one, we're gonna check schedule FIFO or RR. So we're gonna schedule a FIFO process, or we're gonna schedule a round robin process. See if there are any runnable FIFO processes in the table. Okay. Number two, what we're gonna check now is we're gonna see like, okay, so now we schedule the best FIFO RR process respectively. So we're gonna have two separate kind of logic blocks for FIFO and for RR. So we'll be looping through the process table twice probably. Well, actually, so for now I think about it, for FIFO we probably won't need to loop through the process table at all, because if we manage our linked list right, we should always have the best process to run at the head of the linked list. But maybe it won't be. Maybe it'll end up being, it'll like go to sleep or something like that. But if it goes to sleep, we should take it out of the list. I don't know. We'll figure it out. We'll figure it out. So here, okay. So let's do. So I mean, we're gonna have a so our four. So for first of all, yeah. So we'll have our four. Basically, we're gonna just loop through the whole. I'm just copying that condition. This is actually gonna go to and p table dot proc and proc. All right. Cool. Okay. So yeah. So how I'm going to do this is I'm essentially going to say, okay, so if we have a process that is runnable, and it has a FIFO scheduler policy. So if it's runnable and it's a first in first out process, then we're going to set some flag. I'll just call it like I'll just call it the FIFO, just FIFO, and we'll set it to 1, I guess, and then we'll break. Right. So that requires me to make a little flag up here, which we can do. So we'll say FIFO equals 0. So determine whether to go into FIFO or RR scheduling logic. This might not be the most like efficient way to do this, but it's probably the simplest way. But yeah, okay, so we'll do this, and then essentially what we'll do. Oh, and let me set FIFO to 0 up here. Which honestly, in that case, we don't actually need to. We don't need to set it at the beginning here. Not that it matters, but I don't know. I feel like it's just cleaner. But yeah, okay. So FIFO equals 0. Then FIFO will equal 1 if we find a FIFO process that's runnable. And how we're gonna deal with that is now outside our for loop, we'll say, okay, so if FIFO, right? Then we want to do FIFO scheduling logic, which I think will essentially just be pull like head from wing twist or I'll call it the Fifo Q. And then we move head pointer to next process, right? And honestly, what we can probably do also, what I'm actually thinking about is we can oh, you know what's even a better idea? Okay, hold on. What's an even better idea? So let me go into proc.h real quick, because I want to actually define something. So let's create a Fifo Q. Okay. And so this is gonna be a linked list, right? So we're going to have struct Fifo Q, right? So we'll have that. I actually want to do that down there. Okay, so this is going to have a struct proc head, or hold on. I'm trying to figure this out. Yeah, so struct proc head, it'll have a struct proc tail. So what I'm trying to do essentially is here, if I open up my little paint window here, right? So what I want to do is, if we have all these processes in our linked list, I mean, we all know how linked lists work, right? So you basically just have a pointer from one to the next. So I want to have like a dummy head pointer at the beginning, and then I want to have a dummy tail pointer at the end. And I think what this will help us do is essentially, instead of me having to me having to reassign a head pointer to this node, like to this node specifically, or like if there's like no head pointer at all, I can instead just say like, oh, like let's just erase like this like pointer here, and we take out this process, right? And then we make the dummy head point to the next process in the Fifo Q. And then whenever we need to query, we can just say, oh, dummy head dot next, and that's always going to be the head of the linked list. So we could do it that way. And how that's useful is that now we don't actually need a like a separate Fifo Q struct. We can just do like Fifo Q like node. Fifo Q node, right? And then all we need to hold here is we need a struct proc pointer next. Like that's literally it. So we'll have one so we'll have one that's called head, and we'll have one that's called tail. And then head will always point to head would point to tail at the beginning. Yeah. And that should never that should only change if we put something in the middle, essentially. So the nice thing with having the tail then is that your head will never point to like nothing. So you don't have to like check for that. You don't have to check against like, oh, is next pointing to null? You can just check, oh, is next pointing to tail. And that would mean that the Fifo Q is empty. But like I don't know, maybe even that isn't like, I don't know. We'll see. We'll see. We'll see. But yeah, we're gonna have some like logic that we have to write out here, and that's making me be in pain. All right, where do we write out this logic? I guess I could just start doing some like, what am I trying to say? I could start putting some things in here, some function like decorators. So let's do like, I don't know, like add node. So void add process, add Fifo, I guess. Sure, add Fifo sounds good to me. And this is going to take a struct proc pointer. Okay, so we'll do that. We'll do like pop head. That will be useful. Right. Oh, actually, in the Fifo node, we also need to have like, other than just the next pointer, we also need to have. Oh, and actually, the next pointer shouldn't point to struct proc. It should point to struct Fifo Q. I'm stupid. Fifo Q node, and then struct proc. We should have a struct proc pointer. We'll just call it P, because I don't have a better name for that right now. But yeah, add Fifo can essentially just go from, it can start from like the head and then just keep going back until it finds a good place to put it, I guess. Okay. So add Fifo and then pop head. I think these are the only two functions we actually need, if I'm not mistaken. So let's implement these now. So we've created our Fifo Q nodes, head and tail. I don't know. I'm just like thinking like, um, I'm trying to think about how, because I don't know if we have access to, I don't think we have access to malloc here because we're like in the OS, right? Like we wouldn't be able to just create a Fifo Q struct out of thin air. Um, so honestly, what we might have to do what we might have to do is like add a field directly to um the proc struct. Okay, wait, hold on. How are these processes allocated? Let's look at that. So alloc proc, we acquire, we create a process. Uh, where is that? Where are we creating this process? Oh, so we're actually using calloc in order to allocate like a stack and everything to it. Oh, so okay, so all the process pointers are actually just it's just pointers to the process table directly. Interesting. Hmm. How do I keep track of that? What's a good way to, because I don't think I can like actually. Hmm. This is tough. I think I can still. Hmm. No, this is. Yeah, I don't think we'll be able to use this like idea with the with having like a FIFO Q node, really. Like we'll have to like make like a like static like head and tail process pointers. And then we'll have to add like a um maybe like struct. Oh shoot, hold on. Proc pointer next. Like directly to the process um like struct for Fifo Q. Maybe something like this. And then we don't need this. Because here we can just say, oh, let's just create like struct proc head tail. And then that way for head and tail we can just say like the priority for head. Well, I guess we shouldn't even be checking head, honestly. Head is just like a dummy pointer essentially. For it like makes our operations easier. So we'll never need to check the properties of head, and then tail. We can just make it like 0 FIFO and then priority 0 or something like that, so that like things always go in front of it. Or wait, no, that wouldn't work. So we'll just check if like the next pointer is tail or something like that. Okay, yeah, we'll figure it out. We'll figure it out. Okay, so I think yeah, in that case we'll probably need this like next pointer or something. So okay, in that case, so now what we have to do is we have to say, so let me create. So we said void add FIFO, which isn't too hard, and that's gonna take a struct proc pointer, right? And then we're also gonna have void pop. What did I call it? Pop head. Yeah. And that's not gonna take any anything there, but that will return a struct proc pointer. P. Okay. Oh wait, no, not P. It doesn't matter. Oops. There we go. I don't know if that's the best way to annotate that, but oh well. Okay, so it's pop head, right? Why is it declaration is incompatible with? Oh yeah, I need to change it in the in here too. There we go. That should be good. Cool. And pop head does not need to take any arguments. Cool. So pop head, literally all this is gonna do is it's gonna say, okay, let's get head. So struct proc key is gonna equal head dot next. Right? And then what we'll do with we'll say p dot next. Or sorry, so then we need to do head dot next is going to equal p dot next, right? Because we want to remove that node from the linked list, and then p dot next we're just going to set to I don't know, 0. Sure. Or I don't know. Should we just say void 0? I don't know if that. I don't know if we even need that cast. I'll just say 0 for now, and if the compiler gives me a you know, an error about it later, we'll be like, oh, maybe it wasn't that.
Yeah, I need some water.
It ain't the same without Akshay's hydrates in chat. But yeah, coding streams are definitely gonna be slower. Well, I mean, my last coding stream actually went pretty well. But that was a kind of a surprise, honestly. I think it was, I guess. Yeah. So I guess add FIFO will be the slightly harder part here. Oh, and then obviously we need to return P. And oh, you know what would be really good? If we can have okay. Just follow me for a second here. Okay, so if we can have pop head, so if head dot next is equal to tail, right? Then we can just return tail without doing anything, right? And then when we're like outside here, oh wait, return tail. What happened? Oh, return. Wait, let's say return and tail. If head dot next equal and tail. And we'll need to like, I don't know. We'll probably need to like set this somewhere. Like when we initialize stuff, we'll need to like set that, like head dot next is tail or something like that. I'm not really sure where we would set that. Maybe P. Oh, maybe when we initialize the process table. I don't know. There are definitely multiple options here. I think when we initialize the process table might be the best, actually. We can try that. We can try that, actually. Yeah. Initialize Fifo Q. We're gonna say head dot next equal to and tail. That's all we need to do, actually. I don't think we need to change any other parameters or anything like that. Not required. So yeah. Okay. Yeah, okay. So we do that. So now this guarantees that head.next starts out as being equal to and tail. And we wouldn't be able to do any scheduling before the P table was initialized. So I think we're chilling. Chilling there. Okay, so here we're gonna add a Fifo process. Okay, so we'll start at so we'll say um for what am I trying to say? Sorry, we need another pointer here. Oh wait, no. We can put it in the for loop directly. I'm stupid. Struct. I'm gonna say cur. Or struct proc pointer cur is gonna start out being equal to head dot next, right? And then we're gonna go while cur is not equal to tail, or not equal to and tail. So if head dot next is tail, it won't even go into the for loop. It'll immediately exit. So you see, like that's how these like head and tail dummy pointers are like pretty useful actually, because you don't have to like deal with any of that logic of like, oh, what if there's nothing in the list? I honestly wish this is how they like initially taught us in class how to do this. They taught us afterwards, and I was like, honestly, I feel like we could have just done this first. It's not that much extra overhead. But yeah, head next, and then and tail, and then here how we're going to iterate cur is we can just say cur equals cur dot next, I think. Oh, next. There we go. That should be valid. I don't think I've ever tried doing something like that, but it's technically an assignment clause, so yeah, okay. So what we'll do here is we'll say, okay, so if well, actually, you know what? We'll need to keep a yeah, we'll need to keep a record of like the previous process also. Struct proc key prev, and we'll start that off as head, or and head rather. Okay, so we'll say here. So if so basically, so if if p is better, or wait, no, do we want this? I guess we want this to be. I'm just trying to think about like with the Fifo Q, like, do we want the Fifo Q to also sort priority, or do we want it to like just be like when did it enter? That's what I'm wondering. I think it would honestly it would be better for it to also handle the priority part, so that in my scheduler I can literally say, okay, pop head, that's the one, we're done. Like we don't have to do anything else. We can just keep track of all of this stuff like right here. I think that might be better. So P is better to schedule than cur, and then we're going to place P here in Fifo Q. Okay, so so this is like strictly better, right? Which means that we're still preserving like the time order. So if we have a bunch of so if we have a bunch of processes in our FIFO queue, right? Like say these are all like, I'm just gonna write a priority in them. So let's say it's like 1, 1, 1, and then like 0 over here. And I want to insert a priority 2 process. Like obviously it's gonna go here, right? But let's say instead I wanted to insert a priority 1 process. I don't want it to go here because it's not first. There's already 3 in the queue that have the exact same identity essentially. So instead I'm gonna say, okay, not here, not here, not here. It's actually gonna go all the way right here because it still has a higher priority than this last one right here. So we still want to run it before the 0 priority process, but it shouldn't go in front of any of the ones that it has the same priority as. So I don't need to close that yet. It'll come in handy again, probably. Okay, so if P is strictly better, right? So P dot priority strictly better than her dot priority. Then we want to say, okay, so prev dot next is going to be equal to P, and then P dot next is going to be equal to her. And that's going to be it. We don't really need to reset P dot next to 0 here, because it will get reassigned when it initially goes into the thing here. Okay, so that works, right? And then here we could just return, like that's it. Like we don't need to do anything else. So and then the edge case that we need to handle here is basically say like, okay, P it should go at end of Fifo Q. So here then we'll say, okay, basically we just need to set, we need to like, so prev, right? The previous header. Oh wait, hold on. We need to actually iterate that. Iterate prev. So prev will equal prev dot next. Nice. Okay. So here we'll know what the last process is because prev would have iterated all the way. Right, because we go until her is equal to tail, so prev will be equal to the thing before tail. So we'll say here we literally just do this, right? Let me fix the formatting. I don't know why it got screwed up so much. And then instead of cur, we're gonna set p.next equal to tail. So that's how that's gonna work. Oh, sorry, and tail, because it is not a pointer. Okay, so that should work, and then that'll automatically return. We don't need to deal with that. So I think these two functions are fleshed out pretty well actually. So we should be good there. So now we just need to find the places where we need to actually use these. So pop head will only be in our scheduler, right? Pop head will literally be, I don't know, I said pull head. Pop head from Fifo Q. That's all we need to do because it's all abstracted. Pop head from Fifo Q, and yeah, that's all we need to do. So we'll say that best is gonna just be equal to pop head. Okay. Yeah, that's it. That's all we have to do there. And then in terms of like actually adding a process, that we will need to take care of. So there's two places. One spot is in set scheduler here. So set scheduler, this is how we're modifying our process. To say like, oh, like, I want to change this process to be a Fifo process. So here what we'll probably need to do is, yeah. So what we'll do here is we'll say so before we set our policy and our priority to like what was requested, let's actually do a comparison. Check if we need to add process to Fifo Q. or like remove it from? Like what if a process gets set um from from FIFO back to round robin? Remove process from FIFO Q. So if if p dot policy, so if the current, or sorry, not priority, policy is greater than the policy we're trying to adopt, which, look, there's only two policies right now, so this would mean that that the process is currently FIFO and we're trying to set it to round robin. Then we'll need to make a remove FIFO that goes through and looks for p. So we'll all make that function, and then we'll have to do else if. I don't know if I like putting spaces after my ifs or not. I like haven't been able to decide. I feel like I don't like it, but I keep putting them there just by habit, and I'm not really, I don't know. Anyways, otherwise, if p dot policy, the current policy, is less than the policy we're trying to implement, then that means that we need to add it to our list. So okay, so let's make a, so we have add FIFO, and we need to have remove. And I don't really care if what it returns. I'm sure it'll be fine. So yeah, okay, so remove FIFO will probably work pretty similarly to add FIFO. I just want to put these in the same order because I don't know, I kind of like that. Remove FIFO. Okay. Yeah, again, we'll need to keep track of the previous pointer and the current process. Okay. And we don't need to look at priority or anything. All we need to look at is if cur is equal to p. And if that's true, then we say previous.next is going to be equal to p.next, right? Next. And then this way we that's actually all we need to do, honestly. All we need to do is reset previous next pointer. Like p's next pointer doesn't really matter if we're removing it, because we're gonna reset it when we put it back in the queue anyway. So yeah, that's pretty much all we have to do there. And then this doesn't matter. You don't need that anymore. If it's not in the queue, then like I don't really care. I'm not gonna like be like, oh no, it wasn't in the queue. Yeah, it's whatever. So that should be fine. I think that's the only situation in which we actually remove a process from the queue without it like, oh, okay, well the other time we'll remove a process from the queue, and not just like be popping the head, is in the case where a process goes to sleep. Or if it gets killed, actually. If it gets killed, we should remove it. Now that I think about it. So yeah, so here let's remove FIFO. In case it is, well, actually, if it's in, no. Now that I think about it, if it's in the, so it can only get killed if it's currently running, right? So it won't be in the queue anyway, because we would have popped it off the queue. It won't be in there anyway, so we don't even need to put that in. That's just not required. Okay, what is required though is here in oh, you know what we should check for like add FIFO? We should probably check so if p dot priority is not equal to FIFO, then we should just return. Like it doesn't, we don't want to do anything. We don't want to put it in our queue at all, right? And I mean, we could do the same thing with remove FIFO, but I guess we can. It's better for efficiency. Okay, but what I was gonna say here is that on each iteration of wake up, what we can do is since these processes are getting set to runnable, right? We want to add these to our Fifo Q. Like if they're not already in the Fifo Q. I mean, they shouldn't be if they're sleeping. Is the thing. So that brings us to sleep, right? So if we're sleeping this process, then we're setting it to state sleeping. I mean, like I feel like that's pretty self-explanatory. So before we enter the scheduler here, let's remove process from Fifo Q if applicable. So how the way we were able to do this now is like we have our if condition kind of embedded in the function, so we don't have to put it here. We can just say remove Fifo P, and if P isn't a Fifo process, it doesn't matter. It just won't, like the function will just return. So I think that works there. Maybe we'll see. I don't know. Is there anywhere else that we need to remove from the Fifo Q? Oh, well, we'll need to, when we yield, we'll need to add it back to the queue. Right? So since it's runnable now, so let's add FIFO. So again, if it's applicable, iproc. I think that's it though. I don't think we should need to do this anywhere else. Of course, we also have to check if my linked list even works. Haven't coded one of these in a little bit, so you know. There's always the possibility that it does not work. Yeah, I think that's it. I don't think we should need to like adjust anything anywhere else. Yeah. Okay, hopefully that is everything that we need to do. Okay, so here then we need to have an else clause here, right? So else, and this will take care of the round robin scheduling logic. So here we're going to loop through process table, find best process. And the way we want to loop through actually is since it's round robin, right? We can't just start from the beginning every time. So we need to kind of have this concept of like the front half and back half. So let me kind of grab let me just grab the what you call it here. check front half, check back half. Yeah. Okay. So let me grab that. So this will be for our front half, this guy. And then for our back half, oops, I went way too far. For back half, we're gonna want this guy. I was trying to figure out how I wanted to grab that. So how we'll want to keep track of this. So this current pointer, essentially the reason we need it at all is is because we want to know the current process that's running so that we start looking for the next process starting from that process, and if that makes any sense. Don't start. Oh, that's better. Where are? Yeah. Okay. So basically, if we go into this loop at all, hold on. There's a better way. There's a better way to organize this. We don't even need to loop through the whole process table one time, right? Because we already know that, like, so if here, this is gonna be so big brain. So if best equals pop head is not equal to, or it is equal to tail, right? So if it is equal to tail, then we do round robin scheduling logic. So our new method is actually check if Fifo Q is empty, I guess. If it is, schedule best our process. Otherwise, schedule head of Fifo Q. Right. So this will set best to pop head if it isn't equal to tail. Or well, I mean, it'll set it regardless, but I guess this is useless. So hold on, actually. So we'll actually want to reset best in here, now that I'm thinking about it, just in case. Because like otherwise we'll be comparing to a Fifo process, which isn't being considered. Or we'll be comparing to tail, which is not something we want to schedule. Yeah. Anyways, so we start from wherever P is at currently, and then we want to end at cur. And the reason we want to end at cur and not start at cur is because we don't want to. It's round robin, right? So we don't want to reschedule that same process unless it has a higher priority than any other process. So we're essentially kind of like subverting that. So here we're gonna say, so if we can first say, so if p dot state not equal to runnable, or actually the other way, I guess the other way we could phrase this, if p state is runnable and not best, so we have to check like if best is even set, right? Like best could just be 0 right now. Possible. It's possible. So if best is not set, or key dot priority is greater than best dot priority, right? So if any of this is true, then we'll want to say, okay, so now best p is the new best process that we can run right now. And we'll want to do the same thing here also. This setting sync thing for Visual Studio Code does not work very well. I wish it worked better. Just put me on dev div at Microsoft. I'll figure something out. No, I probably wouldn't. That stuff is like so complex. I don't know. I guess I'm with setting sync specifically. I'm surprised that it's like so buggy. But like Visual Studio Code as an application, there's so much going on. There's a lot there. But yeah, okay. So best, whatever. So yeah, so if best never gets set, which like it should, but I don't know, maybe there's like no processes at all. Okay, honestly, wait, you know what? This should just never happen. This should just never happen. So we don't need that. Whatever. Because we're always looking at cur. Unless there's no processes in the process table, which is like, in that case, like you wouldn't have even gone to the scheduler, right? Actually, I guess there is the situation where best never gets set. But in that case, we just need to continue to the next cycle. We just like, because like there is a situation where there aren't any processes to run. And best would not be set in that situation, so we just need to continue. Yes. Set best to 0. Also. Where did I go? Oh, here we go. Okay, cool. All right. Well, I think this should work now. I don't actually know. So the way that the FIFO thing is gonna work now, right, is like if we yield here, then we're going to, what did I change in here? Added sketch. Oh, I don't need that. Okay, so this file is like completely unmodified now, theoretically, but it still says it's modified. Shouldn't be anything different about this file now. I don't see any changes. I don't know, man. Yeah, I'll just discard just changes. It was probably like a line ending or something. I wish it was like more visible, but anyways. But yeah, we shouldn't need to like worry about that timer thing now, because when we yield, when we yield, we add the process back to the Fifo Q. Again, if applicable. So yeah, so it shouldn't matter, I think. We'll see. I don't think there's anywhere else. I should just do a quick search, actually. Let's do a quick search for sleeping. So here I remove it from the queue. There, I mean, yeah, I'm adding it back to the queue since we're setting it to runnable. Same thing here. I mean, well, in kill, do we even need to? I don't know if we even need to. Oh, Klaus, thank you so much for the follow. I appreciate it. Thank you. I don't know if we even need to in kill, if we need to remove it from the queue. I guess it can't. I guess it can't hurt to remove it from the queue. I'm trying to think. Oh, that's right. So I didn't remove it. I didn't remove it from the queue. Because it wouldn't have even been in the queue. Because since we're killing it, right? Since we're killing it, that means it was actively running already. And if it was actively running, then it couldn't have been in the Fifo Q because we would have popped it off the head. So yeah, that's not even possible. So I think we're fine there. Okay. And then one more. P8 sleeping. Um, get Paul color PCS. Okay, I don't think we need to worry about this. Oh, this is just a dump. Yeah, we don't need to worry about that. Cool. All right, you know what? I think we just have to try it, right? Just have to try it. So let me launch this Docker container. And what is this shell? I don't know. Then we'll get another. Actually, we don't need the second shell yet. We might need it though. Potentially. Okay. Make queen. Make. I don't know if I actually have to make queen, but I feel like it's probably just better in case. No semicolon at end of struct or union. Oh, really? Wait, what? Wait. Oh, shoot. I didn't put a semicolon here. That was actually a rookie mistake. Oh, well. Okay. We'll make. Oh, there's more problems. Statement with no. Oh, I would do something like that, wouldn't I? I'm making so many rookie mistakes. I'm glad that C is the compiler is catching them, but God. Oh, and then yeah, since I removed the original way that we did our FIFO logic, we don't need that anymore. Okay. That should be everything. Maybe. Pause chat. Okay, cool. It made, which doesn't mean anything. It just means it compiled. It does not mean that anything runs correctly. Unfortunately. Imagine if you could just compile something and it ran perfectly. That would be amazing. Yeah, alright. Well, I was kind of expecting that. I was kind of expecting this to happen. Okay, what's actually... It's not exiting. There we go. Let's actually put this in debug mode, right? And I can come in here. I can attach to the same container. I'll cd in here, and I can use GDB in order to breakpoint through this. So let's breakpoint at scheduler. Continue. Okay. So we're gonna run through scheduler. Ah, okay. So our So our trap occurs. So there's trap 14. What is trap 14? X86 trap 14 exceptions. Oh my god, this wiki takes so long to load. Come on, come on. This is such a shame. Maybe if I reload. Eh? What if you load this time? Oh wow, OS dev just doesn't want to load. That's crazy. Alright. Well, maybe they're getting like DDoS or something. That'd be kind of unfortunate. It is a useful service. Interrupt and exception handling on the thing. Oh, so it was a page fault. Page fault. How are we getting a page fault? So we page fault when we try to enable interrupts. And this goes into an ASM file. Let me look at what we have as far as ASM goes. Oh no, that wouldn't be it. Would be in source ASM. STI. Or wait. I don't know. Maybe we can search like STI page fault. Okay, so this has happened. Oh, this is also on OS dev. It's probably just not gonna load. What is going on with OS dev? What happened to OS dev? I need you right now. Because I'm developing an OS. Ah, this is so sad. Why? Wait, I wonder. Hold on, hold on. What if? Do you think I'd be able to like? Can I like take this link Wayback Machine? Can I put it in the Wayback Machine? And like, will it'll pull up something for me, right? Maybe. Okay, took a snapshot April 12th. Oh, dude, I'm so smart. I'm so big brain. Okay. Hi, I'm writing a 64-bit kernel, managed to boot using my bootloader, switch to protected mode, yada yada yada. Managed to set up my IDT, set up IRQ 0, PIC works fine, clock ticks no problem. Just for enabling IRQs, I had all my interrupts cleared. As soon as I issue STI, I start getting a page fault exception. CR2 has the address, whatever, above 1 gigabyte with, yeah, okay. Ensure that you're, I mean, this doesn't, like, none of this seems like something that I'm actually developing in this. Like, this is all stuff that exists. I don't know what I'm doing. I don't know what's going on here. Maybe we can do like a backtrace. Okay, so it goes into the trap handler. That's not very helpful. Let's try restarting. I'll try to like step into it this time. Oh wait, no, I have to start GDP before I can set a breakpoint. Continue. Okay, next. And here we're gonna step in again. Okay. So we're in the scheduler line 337. Wait, isn't that past? Yeah. So we're requiring the p-table lock now. But when I tried to go next from STI to acquire it, the page faulted. Okay, so now we're in acquire. So we disable interrupts. Okay. So we're in the, okay. Disabling interrupts. Cool. What is CLI? What is CLI? CLIX 86. Clear interrupt flag. Oh, I see. Is that, I guess that's the equivalent of like that's disabling interrupts? Okay. So that will just do a thing. Okay, so then that, okay, so then we're going into my CPU. We come back out of that, I think. Oh wait, no, we're reading the eflex again. I see. Cool. Okay, so we reset the antenna. I'm just gonna start nexting because it seems like my CPU is not the issue. Okay, here we can step again. Okay, so holding, if it's holding walk, we yada yada yada, we and we. Okay, so we're holding the walk. Pop cleave, turn R. Okay, so we have atomic exchange explicit. Locked memory order. Okay, so wake up. The wake up function is what's causing this. Wake up is causing this issue. So something I wrote in makeup. Let's see. So what I can do this time is I can just breakpoint at wake up directly. And then here, I can actually look at what causes this. So it's probably something in wake up 1, right? It has to be. So here, okay, so we check, okay, is p dot state or p state sweeping, and if it's on the channel, so we're just gonna go through like every single one, I guess. What's the first one we're gonna find? Something is gonna be woken up, and that waking up is gonna cause a panic. It seems like. That's what it seemed like. Dude, I'm just gonna keep pressing enter, and I'm gonna accidentally press too far or something like that. I guess I could breakpoint. Hold on, I could just breakpoint so that we go to the next line. Where is this? Yield. Wake up 1. Okay. 575. Or wait, no, it would be something in I add FIFO maybe. Or would it, or actually would it be something out here? It could be something out here. Let's see if, hold on, let's breakpoint at 590. Okay, so it actually makes it out of wake up. I actually want to see. Okay, so there's nothing in the Fifo Q right now, which makes sense. There shouldn't be anything because nothing, like on just the boot up process, nothing is actually set to Fifo. So like that makes sense. Okay. So yeah, I guess it makes sense that nothing would happen in there. So something's happening here then in the for loop, right? It has to be something with the way I'm yielding maybe. If policy equals myproc.policy or myproc.policy. Is it something with the fact that I'm calling myproc? I mean, that's the only thing I'm calling here. Like release, I don't think would cause an issue. It could be yield, I guess. Here, let's try stepping in. So we're stepping into myproc. We get my CPU p equals c.proc, pop cleave, return p. Okay. Interesting. So is this where issue happens? So we're going into all traps. And then yeah, we trap. So what is here, let me cancel out. What, so we trap on this address. Like what is this address? Like I legit don't know. Like when are we calling this? So we were in my proc. And it looks like it ran all the way. Like it returns P. Like my CPU seems to have returned fine. We have a trap. We have a page fault. Where did we have a page fault? I don't understand. Is it because the P table is locked? But like I have to lock the P table, don't I? In order to like iterate through this? I can try deleting this stuff. I can try just putting this right after, because this is how it was originally written. Like right after the wake up, I would release the clock, and then this wasn't here. But I can try doing it like this instead, where we just don't lock at all. I feel like that's wrong though, and I feel like it's not gonna work anyway. But we can try it. We'll see. We'll see. This is for a class, so I might have some TAs that can give me some advice also. There's probably something stupid I'm doing, honestly. Okay, yeah, we're still getting an issue. We're still getting some sort of trap. On wake up. So it's something about calling my proc. It has to be, right? Like that's the only function I call here. I never make it to 597. I don't think I do. Hold on. We can try breakpointing on yield. Yeah, I never even make it to yield. I never start running it. So it never actually gets through this whole thing. And I don't think it wouldn't be correct to just yield like on a win either. So why are we unable to check this this condition? Let me just look and make sure I didn't do anything stupid. Okay, hold on. So P.policy or P's policy, the process we're currently looking at. And this failed on like the very first call, right? I think. So we go to wake up. And we get to the for loop. And that if fails on the very first time we try to evaluate it. I don't think there would be any issue with checking the policy or the priority of my proc. And that's all we're doing. Those are the only two like fields that we're checking. Unless, okay, the only possibility that I see is that maybe what does my proc return if there is no currently running process? Or null, right? It could be null. That could be the reason why we're getting a page fault. Actually, that probably is the reason we're getting a page fault. So I need to do like a null check. So I guess. So what we'll do then? So we can do a checkout here. We can do if my proc, and we'll just say like if not my proc, no process running currently. Schedule new process. So we could just yield by default. Here. And then we'll say otherwise we'll do this whole for loop thing. And we'll need to release our key table lock also. And then yeah, if my proc is set to something, so if it does actually return a process currently running process, then we'll be able to evaluate this if statement. I think that's probably what it is. Okay, hold on. Let's try it. Let's try making. Imagine if that was the problem this whole time. Okay, well, it wasn't. But it was a good try. Interesting. I don't know. I really thought that was it. We can try. Let's try breakpointing again. I'm gonna breakpoint at wake up again. I don't know, man. This is whack. Breakpoint wake up. Okay, so we know it's on wake up 1. Oh. So yeah, so in this case there was no so my proc was set to 0. It was null. So we yield. But now in yield we're getting an issue. Or wait. Well, I guess if there's no currently running process, then we wouldn't yield because there's no process running. So how do we deal with that? Yeah, because my proc state, yeah, this won't do anything because there's no process running. So how do we? I guess that makes sense. So yielding doesn't make sense, I guess. So I guess we just return. I guess we just return. I don't know. Just return, yeah. Maybe it'll take care of itself if we just return. That is a possibility. Let's try it. Okay, I'm glad we were able to like kind of figure this out though. What the hell is going on? Okay, maybe not. I swear it was gonna work that time. Okay, we can breakpoint at wake up again. And so we're gonna go into here, we're gonna return, right? Where do we go now? Okay, so we go to a trap handler still? Wait, but then here it tries to call my proc, even though there is no running process. Oh, I guess that's why it's checking if my proc and. Okay, so it'll exit out of that. Okay, so now it's gonna go into the scheduler. So now we're in the scheduler. Oh wait, no, we're back in wake up. Oh, okay, sure, we're waking up something. Yeah, okay. We go through our trap handler again. Okay. We keep getting pushed into wake up. Wait, hold on. I want to put a set of a breakpoint at scheduler. Oh, because I think that might be the next issue. Huh. So we keep breakpointing at wake up, and then eventually we have some sort of issue. Huh. Interesting. So and it was still a page fault. So it was, I think it was on like the fourth call of wake up. Okay, well this time I just trapped at the on the first call, which is fine, I guess. I don't understand what's going on. It's so weird. Let's try, I don't know. We can try breakpointing at scheduler this time. I mean, that's the only other thing I've touched for the most part. Okay, so we do make it to the scheduler. So we're gonna go through this whole thing. We do that. We don't find a so this is where we are right now. In here. So we don't find a process that is marked as a FIFO, which is correct. So we do that, we do best. We're gonna just cycle through Oh, okay, wait. And so now we have some sort of we have another page fault here, looks like. Maybe. So what so okay. This page fault. How did we cause this page fault? We read p.state. Wait, oh, wait, no, we do have the p table block acquired. That shouldn't matter. And then we release it here. That shouldn't make a difference. So okay, let me get back to that specific line. So how we're gonna do that is we'll open this with GDB, and then I can just do scheduler, right? And then when we continue, then once we're in scheduler, I can just say, okay, go to line 430. Okay, so let's see what our variables are here. So okay, so P is actually so P never actually gets set on our first iteration. So we need to make sure that we set P on our first iteration. So if not P, then P equals, and we want it to be set to the first address. I see. Okay, that's actually kind of an easy mistake to make. So glad we caught that. Okay, so we'll need to remake this. That should be all we have to do there, though. I think that. Hopefully, I'm really hoping that's the only page fault. Okay. Pause jam? Panic on acquire. Okay. That's not good. I don't think I did any acquire stuff in. No, I didn't do anything in there. That wouldn't have made sense anyway. Okay, so let's find out where this one's happening now. I'm gonna assume that this is also happening in scheduler somewhere. I'm just gonna go ahead and preemptively breakpoint at scheduler. And then we'll just go through this whole thing. Oh, and then I don't want to actually go through this whole for loop, so I'm just going to breakpoint at 450 so that we exit out. Okay, so we found a process, right? So we have some P curve. We can look at this process actually. So we can see our size, we can see our page directory, our stack, and all that stuff. So we can see it's actually a runnable process, which is good. That's what we wanted to select. Policy is 0, which is if we look at our definitions here. So, oh wait, did they set FIFO to 0 and RR to 1? That would mess things up for my code. I didn't expect them to switch it on me. Okay. I just assumed that the scale would be the same as FIFO. Instead of actually going through and changing my code, I'm just going to change this right here. I don't think this is the problem, but we should change it anyway because it's incorrect. Yeah, I didn't think it was the problem anyway, but that is wrong. GDB, not gettable. Scheduler. Okay, so run, and then we're gonna breakpoint at 450. It was. Continue. Okay, and now we're here. So P, curve, right? And if we do a little asterisk there, then yeah, now we see that our policy is 0, which it should be set to round robin by default. Our priority also 0, which is the default, and next is set to the null, which is correct. Okay, cool. So where are we now? We are. So what line is this that we're on right now? We are on line 456. We are right here. So we're gonna add 1 to P. We're gonna set P equal to the current process plus 1. So that we don't start at that same process on the next iteration. Okay. And then we set the CPU's the CPU is currently running process to that process that we just selected. We're gonna switch to user virtual memory, set the current process to running, and then we're going to actually run the current process. Then we'll switch back. It runs, it does whatever. And then we move on to the next function here, or the next scheduling. And then we come back, we acquire again. Again, we don't have anything to schedule. So now we're going to come back down here. We don't have a best, or we do have a best, so we're not going to, continue or anything like that. And we just keep doing the same thing, basically. So where are we page faulting? I haven't seen that yet. I have not seen the page fault happen. Oh, wait, hold on. So it actually prints this time. Okay, and then so then there's the panic on the acquire. But we acquire so many times. It would be so hard to like find the specific instance where it's failing. Cause like, I mean, our backtrace is probably useless. Because it goes through the oh wait, actually. Okay, so we panic, acquire. Okay, and wake up. So in wake up we try to acquire 591. So here we try to acquire the lock and we're unable to. Because I guess because something already has it. And okay, so then this is in spin lock. So something is something else is this CPU is so we're already holding the lock. And so we panic because we already have it, I guess. It would be nice if we could figure out where all we're actually acquiring the lock. I mean, I guess I can just do a search for that. Acquire, or better yet, we just do like a go to references. We can look at everything in proc, but it looks like the specific place that it failed was in. It wasn't wake up, yeah. So somewhere else, I'm supposed to have unlocked, and I didn't. I guess. So there's a lot of places here. So one in Alec proc. I didn't change that. I didn't change this. Didn't change this or this. Which ones have I changed? Okay, this one I did because this isn't scheduler. So here I'll just I'll get this out of the way for a sec. So before, what we used to do is like we would acquire the lock at the beginning of the for loop, and then we would like release it at the end. So like basically the entire for loop would be covered by this lock. Which is the same thing I'm doing now. So I don't think that should be an issue. But okay, we'll keep going. Yield lock, that should be fine. Sweep lock should be fine. And it's not LK that it's failing to acquire. It's the P table lock that it's failing to acquire, right? Because that's what we saw in wake up. It was trying to it was trying to lock P table, but we already had the lock for P table. Is why that's panicking. Okay, and you wake up, we acquire. It would be nice if I had more than just this. Like I don't know what came before this, cause it goes through like the when it switches between the kernel space and the user space, it's like unable to like show that in the stack because there's a separate kernel stack and a separate user stack. So a little bit unfortunate that we can't see the other half there. Not kill, set scheduler. It could be set scheduler. I'll be honest. But it... Ooh. Hold on. Hold on. So this if statement, we release at the end of. Oh, okay, here's the release for the overall for loop though. So that shouldn't matter. So if we exit the for loop, then we release the lock here. And if we yield, then we release it here. So there's somewhere where we're acquiring for too long, I guess. It wouldn't be a problem with either of these functions because they don't even depend on having that lock. I don't know why I don't just return here. I guess I could. There's no reason to reacquire the lock. Okay, where's the other acquire? Where is this one? This one is... Oh, it's just... Okay, yeah. It's just both of those in set scheduler. I can try taking this out and just replacing this with a return. Or return 0, I guess. Sure. Okay. I doubt that changes anything, honestly. Removing that one acquire. But we can, I don't know, we can try it. Better than nothing. Make queen. Make. Then get me out of here. Yeah, I doubt that changes anything. Yeah, okay, I didn't think so. I don't know, where else are we acquiring? Because we need to acquire the p-table lock in order to make modifications to any of the processes. I guess if we're not... Actually, so in set scheduler... I guess after... Like, we don't even need to, like... We can release... We can release, like, right after we finish editing all these. Because we don't need to hold the p-table lock in order to just read properties. I don't think we do, anyway. Let me look at everywhere, like... Hold on. Lock. Does it tell me... No, it doesn't. That's fine. Okay, let's look at everywhere that we actually use p-table lock. Like that I didn't, right? So we initialize the lock there. See, here we're allocating the process. Oh, well, actually, here they are. They're just using it in order to read. So maybe you do need it. I guess you do need it. Darn. It's a shame. So we should actually keep this. Or, well, actually, I guess now, since we find, since we, I mean, we're not looking through the p table anymore once we get to the process, right? Would we still need to... I don't really know how this works. I'm gonna be honest. But yeah, I think we can release here, return 0, and then yeah, release here also, return 0. And then we'll release here if we don't return either of those places. But yeah, I think we will need to acquire the spin lock there. But yeah, I mean, a lot of these I didn't even edit, you know? So, like, this acquire, like, maybe we don't release early enough here? But no, I mean, we're releasing at the correct time, right? We release at the end, we release here. We release everywhere that we would have returned. So there's no leaks or anything like that, I don't think. It would be helpful if there was like a log of like where I'm acquiring from. But that's hard to like implement. There's just so many places. When I become famous? I mean, yeah, but like not that way. No, thank you. All right. Damn. I think I might have to figure this out offline, I'm gonna be honest. I might have to talk with like a TA or something like that. But yeah, I think I'll figure that part out. But yeah, I'll go ahead and end stream for now. Let's see who we can read. Just show some love to somebody real quick. Who could it be? Ooh. This person that I found recently is like walking through Sweden right now. Which honestly sounds kind of sick. Let's go check this out. Well, yeah, I don't have anyone else online that I have recently followed. Let's try it. Let's try the raid. All right, folks. Thank you guys for watching. I'm sorry we didn't really get anywhere, but next time for sure. Next time we'll figure something out here with our scheduler and stuff like that. So, but yeah, until then, thanks so much. I'll see you guys on Monday. Peace.